Okay, hello and welcome to the video. And in this video, we will gain a brief outline about negative feedback systems. And we are interested in amplifiers. That means that basically we have a structure like this, and we have some input voltage, and we want our output voltage to be K times Vi, where K is our gain. So as of now, let's assume that our input voltage is a DC voltage, meaning that it is constant with time, and we would like to realize this using a negative feedback. So what do we mean by negative feedback? So let's say using a feedback means that we look at an actual output. So we have an actual output at that moment, at that very moment, and we compare it to the desired output. And based on the result of the comparison, we control the output. So basically, what we have is we have our desired output, and we have our actual output. What we do is we compare those two entities, and based on that comparison, we control the actual output. So let's talk about this in detail. So for example, let's say we want to drive a vehicle at a desired speed of 50 kilometers per hour. So what we actually do is we look at the actual speed at this very instance, and we compare it with the desired speed, which is 50 kilometers per hour, and do something to control the actual speed. So what we have as of now is we are going at a certain speed, and we want our desired speed to be 50 kilometers per hour. So what we do is we compare the actual speed and the desired speed, and we do something so that our actual speed becomes 50 kilometers per hour. So this is basically like we can sense the actual speed by looking at the speedometer and all. So what is the block of question mark actually doing? So what is this something that we do? And answer to this question will lead us to the negative feedback amplifier. So by comparing, we mean that we take the difference between the desired speed and the actual speed, which means when we are looking at the speedometer, and let's say it shows 40 kilometers per hour. So we take the difference between 40 and 50, which is 10 kilometers per hour. And based on this difference, which is basically the error, we do something in a way that the actual speed reaches at 50 kilometers per hour. So this is how we represent it. And we have our error, which is 10 kilometers per hour, and we do something with it so that we reach at our desired speed. So that our actual speed is equaling to the desired speed. So in our case, in our circuit design, or let's say in our field, we need the same system where we need our output to be K times Vi, and we have a certain output at an instance. And as our desired value is K times Vi, we need to do something so that our output at the instance matches the value of K times Vi. So thus, we need to find out the nature of this system over here, or this box of question mark, or this block. To find this, let's say that there is no feedback, or the speedometer is basically stuck at some value. Let's say it is stuck at 30 kilometer per hour. So what will happen is it will now show us the input that it is stuck at 30 kilometer per hour. So we don't, like, let's say we don't have any mean, but we are totally dependent on the speedometer. And now we are sensing that okay, we are going at 30 kilometer per hour speed, and our desired speed is 50. So the error which we are noticing is 20 kilometer per hour, and due to the mismatched, or due to the fault in the speedometer, we are assuming that there is an error, and we have to do something so that we can reach at 50. So because we think that we are at 30 kilometer per hour, we will go on accelerating, and actual speed will go on increasing with time. And it is represented by this curve, where actual speed is plotted over time. So what will happen is we will keep on accelerating, we'll keep on accelerating, and the actual speed will go on increasing with time. And maybe this will give us the clue for the box. And let's say we are at now let's say we are at 49 kilometer per hour. Now this time the error is only 1 kilometer per hour, so we will accelerate gently. So when the error was larger, we accelerated aggressively. When the error is smaller, we are accelerating gently. So like combining these two curves, we have such kind of behavior, and from this we can tell the nature of this block. And actually what we are doing is the actual speed is basically the integration or the integrated version of the error. So basically this actual speed is nothing but the error is integrated over here, and it is the integrated version of the error. And we will use this principle to derive the negative feedback amplifier in our next video. Thank you for watching.